Welcome back everyone. In this video, I will introduce you to the deposits formed from small fraction partial melts. As explained in my earlier video, these are the kind of deposits that are formed due to low degrees of partial melting, which results in the remarkable accumulation of incompatible elements in the melt and thereby giving rise to an economical deposit. One of the best examples is light rare element ore deposits in Carbonatites. Let us see how this process of partial melting will result in the formation of LREE deposits in Carbonatites. Before jumping into the process of formation of light rare elements deposits, let's have a brief look on what is a carbonatite and why carbonatite with respect to light rare elements. Carbonatites are rare igneous rocks that are made up of 50% primary carbonate minerals such as calcite, dolomite and siderite. Around 500 carbonatite intrusions are reported worldwide. Of these 500 intrusions, many host one or more separate ore bodies containing different combinations of incompatible trace elements and major elements as well. Some of the well-known examples of carbonatite hosted deposits include ores of LREs, niobium and iron at Bayan Obo, Inner Mongolia, China, and at Mount Weld, Western Australia. Resources of titanium and thorium at Powderhorn, also known as Iron Hill, Colorado, USA. Ores of LREs at Mountain Pass, California, USA. Looking at these examples and some other incidents of ore occurrences, one can conclude as of now carbonatites and genetically related rocks are the primary global sources of the LREs. Let me present to you some brief information about the nature of typical carbonatites that hosts LREE deposits before beginning with the genesis of the LREs in these rocks. Intrusive carbonatites occur most typically as roughly cylindrical, composite, approximately pipe-shaped, steeply plunging stalks of up to about 3 kilometers in diameter. However, they can also occur as irregular lenticular bodies as seen in the figure over here. One can expect to find swarms of carbonatite dikes often within a few kilometers of large intrusions. Remember, whilst some carbonatites are isolated intrusions, most are adjacent to or within the complex of zoned intrusions of mafic and ultramafic alkaline intrusive rocks. Since the carbonatites are igneous intrusions, they tend to alter the rocks into which they intrude. The alteration effects manifested in terms of Fenites can be seen in the rocks located within a few hundred meters of the contacts of the intrusions. The process of conversion of rocks into Fenites is called as Fenitization and can be related to the metasomatic process. By and large, carbonatites have the highest concentrations of RE oxides of all crustal rock types. Total rare earth oxide, that is REO concentrations, is about 0.5% in carbonatites, which is around 30 times that of average continental crust. The primary minerals that host REs are Bastnaesite, or more rarely Parasite, and the phosphate monazite. They occur as either disseminated or segregated deposits with grades of up to few weight percent. Relatively not much information is available on the origin of the carbonatites as compared with the most common plutonic igneous rocks such as granites and gabbros. This could be perhaps because of the limited exposures of the carbonatites on the surface of the earth. Wherever they occur, investigations have been carried out to root out the information pertaining to their genesis. Accordingly, it has been interpreted that carbonatite melts are produced by low percentages of partial melting of carbonate-bearing peridotite at pressures about 2.5 GPa and 6 GPa. One of the widely known carbonate mineral to be stable in mantle peridotite at 2.5 GPa pressure is dolomite. Very low percentage partial melting, say of the order 3%, is capable of completely melting the carbonate minerals and produces carbonatite melt. Higher or lower melting percentages have its own implications. For instance, lower degrees of melting may not completely melt the carbonate minerals up to the desired levels that could result in the formation of the carbonatite melt. Similarly, slightly higher temperatures and degrees of melting will result in the formation of carbonate-bearing alkaline magmas. If the temperatures far exceed, then the melt gets contaminated, for example with silicate minerals, and hence may not result in the formation of carbonatites. As you can see in the figure, the solidus of the carbonatite melt is at a higher temperature for the given pressure limits. The implication of this is, as temperature decreases at depth more than 90 km, where the pressure is greater than or equal to 2.5 GPa, the carbonatite melt begins to crystallize. Further, the geochemical behavior of the REEs determine their likely behavior during the melting. It must be noted that all REEs have fairly large ionic radii that makes them too difficult to be accommodated in the crystal lattice of any major mantle minerals. Hence, they tend to accumulate in the melt phase. A small degree of partial melting of mantle that contains average REE concentrations will yield a melt with approximately 0.5% REOs. This percentage is not sufficient to produce the economic mineral deposits of REE. There must be additional processes acting on these melts in order to enrich the concentration levels. Studies on the multiple phases of carbonatite dikes in Bayan Obo, Inner Mongolia, and Mountain Pass, USA, has revealed that the dikes of later phases contain higher concentrations of REEs compared with the earlier phases of dikes. This has led some geologists to believe that the fractional crystallization could be the contributing process in the remarkable enrichment of the REEs in the carbonatites, making them economically significant rock units. Well, it must be noted that the critical factor for the genesis of carbonatites is the presence of a significant amount of carbonate in mantle peridotite. Metasomatism of peridotite caused from the fluids released during metamorphic mineral reactions in sediments or carbonate-bearing ocean crust is considered one of the primary causes of the formation of the carbonate minerals in the mantle peridotite. Interested learners are advised to go through the following research articles to get a much more deeper understanding of the genesis of REE deposits. Well, this is all about the carbonatites and the associated REE deposits. I hope you are now familiar with how low degrees of partial melting could result in the formation of ore deposits. We can always take this hypothesis and validate it for various magmatic deposits of interest in order to prove your deposits. If you have any questions or queries on the topic, please mention them in the comment box below. I'll be back with another episode of magmatic ore deposits dealing with progressive crystallization shortly. Stay tuned to my channel, and if you have not subscribed already, do it now. Have a nice day.